In this video, we are going to talk about solving initial value problems. So we've talked about basic differential equations, and we've been trying to figure out the general solution of this particular differential equation. And we've just had that our function or our y value is equal to this expression. But we've seen that you have this constants, okay? So we've solved all of them, and you can see that you have these constants still with us. So we quite don't know what these constants are going to be unless we have an initial condition. So usually, let's take, for example, the first problem that we did. So we said that y was equal to the cubed root of x cubed plus c. That's what we said. I think that was the answer for the first problem. Yes, it was this. Okay, so let's say that was a solution, and you were actually given additional information. We are given that the initial condition is the following, that y of 0 is equal to 2. Okay, so what this means, so if we were kind of modeling time, what this would say would be that at time equals 0, maybe the temperature was equal to 2 degrees Celsius. I don't know. Okay, so that's basically what it is. We know some additional information about this function. So all we have to do is we just got to plug it in. Okay, so what we're going to do is we're going to plug in 0 for this x. Okay, so we're going to write y of 0 is going to be equal to the cubed root of 0 cubed plus c. Okay, now we know what y of 0 is. Y of 0 is just going to be equal to 2 is equal to the cubed root of 0 cubed, which is 0 plus c. So we have 2 is equal to the cubed root of c. And now let's go ahead and get rid of the cubed root by taking the cube to both sides. So c is equal to 2 to the power of 3 gives me 8. So that means that my solution is going to be y is equal to the cubed root of x cubed plus 8. Okay, so it is possible for me to figure out this value of c if we are given this initial condition. So given a differential equation with initial condition. So if we have an initial condition, something that an additional information, we call this an initial value problem. Okay, and usually an initial value problem, we call them an IVP. Okay, so if we have an IVP, which means a differential equation with a initial condition, then we can try to figure out the value of the constant. Okay, so let's do a quick example of that. Okay, so let's say we want to solve the IVP. Okay, so here is my IVP. So y prime is equal to e to the negative y 2x minus 4. Okay, and the initial condition is y of 5 is equal to 0. Okay, so that's my initial condition. All right, so now let's go ahead and solve this differential equation. So the first thing that we want to do is, I usually, when you're solving differential equations, it's maybe easier to just write it as dy over dx. So dy over dx instead of y prime. That way it's easier to separate the variables. Is equal to e to the negative y, and then 2x minus 4. Okay, so the first thing that I want to do is let's move the dx over. So I'm going to multiply by dx to both sides. That's going to cancel this guy out. So you're left with dy is equal to e to the negative y, 2x minus 4 dx. Okay, now what we want to do is move all the y's over. So let me divide by this e to the negative y. Okay, so what I'm going to have is 1 over e to the negative y dy is equal to 2x minus 4 dx. And you'll see that now everything is kind of isolated. Now, something that will make it easier is to bring this guy to the top. When I bring it to the top, I'm going to have e to the positive y dy is equal to 2x minus 4 dx. Okay? And now finally, what we want to do is now you want to take the integral to both sides. So I'm going to integrate. So the integral of e to the y is just e to the y. The integral of 2x minus 4 is just going to give me x squared minus 4x plus c. Okay. And now what we want to do is we want to get rid of this e. So the opposite of exponentiating is taking a natural log. So I'm going to just take an ln to both sides. Okay, so what that's going to give me is y is equal to the natural log of x squared minus 4x plus c. Okay, so this is technically my general solution. I now have my solution. Now, this would be correct if I didn't have an initial value problem, if I didn't have an initial condition. But since I do, I have an additional information, y of 5 equals 0. All I got to do is figure out what that value of c using this initial condition. So I know that my initial condition is y of 5 is equal to 0 because that's what was given to me. So now all I got to do is plug in y of 5 equals 0 into my regular equation. Okay, so I have y is equal to the natural log x squared minus 4x plus c. So I'm going to plug in y of 5. Okay, so y of 5 is equal to the natural log. So I'm going to have 5 squared minus 4 times 5 plus c. Okay, and now I know that y of 5 is just equal to 0 is equal to natural log 25 minus 20 plus c. And then you're going to have 0 is equal to natural log of 5 plus c. Okay, and now what you want to do is exponentiate both sides. So let me take the e to both sides. So I'm going to have e to the 0, which gives me 1. This is going to go away and have 5 plus c. Okay, and I get rid of that, minus 5. So you're going to have negative 4 is equal to c. Okay. All right, so now all I have to do is just plug them back in. So I'm going to have y is equal to the natural log of x squared minus 4x minus 4. Okay, so this is actually going to be my full solution with the initial condition. Okay, now notice here that I didn't necessarily have to take the ln to both sides. I could have just left it as e to the y is equal to x squared minus 4x plus c. And I think that would have been easier to do because then I can just plug in what y is and I can plug in what x is, and then it's just easier to solve for c. But I actually took this extra step. Now, usually if you have a differential equation, sometimes it might be really difficult for you to solve for y. So for example, something that you might encounter might be, let's say I did separation of variables and I ended up getting like, I don't know, y squared minus y dy equals x dx. So let's say we had something that looked like that. And if I were to take the integral to both sides, what you would have y cubed over 3 minus y squared over 2 equals x squared over 2 plus c. Now notice here that it's going to be very, very difficult to solve for y, because you have two different y's. So at this point, usually what you would do, if it's not possible for you to solve for y, you would just say that this whole thing is your answer. You wouldn't even try to simplify it because there's no way that you can solve for y in these terms. So sometimes it's easier to just do it, just like we did before. And in general, I would want you to solve for the value of y, but there's going to be some problems where you just can't. And if you feel like you can't, then this would just be your final answer. Okay?